All right. Hopefully, it stays like this. I'll have to speak really fast now. Okay. Okay. You guys hear me clearly? Okay. Good. Good. Usually I speak softer, but on the day of presentation, I still go slow, right? Anyway, about myself. Hope you guys know me, Ravi Lobo. So these are some of the projects I have done. I was fortunate to be involved in some of my best projects in Arens itself, right? One of the initial projects I worked on was automating using PowerShell. So I was involved with the team which introduced kind of PowerShell in Arens. So I worked with Curtis and we automated some of the DBA processes using PowerShell. Also, I was involved with a project called ALU. This is a tool we created for admins, non-admins, and that tool has been used in like buybacks and acquisitions and all that. So that was also a critical project. I was fortunate to be a part of that project too. And of late, in the last one or little over a year, I was a part of a project called Automating Store Replication, and I worked with James Tran on these things, and we worked about a year on that, and that is also one of my favorite projects, right? But my most favorite, if I have to rank my number one projects, right, is going to be Store Archival. This is my number one project, and I'm going to talk about these projects today. I mean, people who know me, like I have been talking about this thing for like last 4 years, about Store Archival. 4 years because I'm here 4 years, right? Like if you talk to me for, like at this point, I'm kind of obsessed with this thing. If you talk to me for more than 5 minutes, I start talking about Store Archival, right? People are unfriending me, and people are avoiding me. The presentations which I've given in the past, if you have attended the last couple of presentations, they're exactly the same thing, right? And Peter told me today that you're going to do the same thing one more time, just with a different title, right? So the articles I wrote, like this is one of my articles I wrote in the past year. It has a fancy title, but in deep, what it says is, it talks about archiving data at the stores. That's what it says. And if you follow my posts, some of the posts, like this is the post I did for SAI project, and this is after the project. I posted this summary, and it says what I'm going to do next time. How things are going to be different when I work on this project next time. And I wrote a big essay, and at the bottom line it says containing the data set at the stores. What that means is a fancy way of saying we need to archive data at the stores, right? So you follow my posts, follow my blogs, everywhere. This is the one thing I talk about, and look at the number of likes to the post. One person, right? So one person likes this post, and who is this person? Right? He's my so he's my, like, he doesn't have a choice there. Yeah. But look at what happens when I post something not related to archival, right? This is totally not business related, but 23 people like this thing, right? So they are giving me a hint, right? All right. So for this presentation alone, I did something different because I'm not still want to prefer to be a technical person. I don't do presentations, and I thought I need to do something better this time. So what I did is I read a book called The Presence. It's by Amy Cuddy, and she has a good TED Talk video on YouTube. It is the Number two, video on YouTube. So I highly recommend it if you get a chance. Look for Amika D on YouTube. And she talks about a lot of things. One of the things she talks about is imposter syndrome and all that, but also at the end of the book she talks about, she has few tips for power posing, like you can stand like this, or stand like this, and all that. She says, go to the restroom just a few minutes before the presentation, stand like this, and you get all the energy and all that. So I was reading that, and for some people it comes very naturally. So this is one of the, right? So I thought I will do some Kevin LeClaire, and before the presentation, I ran to the restroom and I tried to do like this, and this is how I. This is my power pose here. Anyway, so we have a store archival channel. If you are not already a part of this channel, please join that. I will try to answer the questions that come up in this session here, and if I cannot answer, I will try to post the answers on the channel. The DB team is here too, so they will also try to answer some of the questions. One help I would need is, let's keep the questions till the end, so we'll have a question and answer session. So let's move all the questions to that part, unless I make some big mistake, saying something like move all the data to DBFs or something like that, then you can stop me. Hey, right. Quick disclaimer. There is some anxiety and anxiousness, like people are wondering, like, are we really doing this right away, right? When are we going to start this store archival thing? Are we going to start archiving this evening itself? This is just an awareness creation presentation. We will not be starting archiving right away. We have some plans. We have identified a few tables. But I guess the priority right at this point is for colo migration. So we'll wait for a couple of months, and I think after the colo is done, the project will get some speed. But before doing any sort of archival, we'll definitely talk with all the stakeholders. We will talk with John, we'll talk with Mike Moore, Birdwell, Mark Swatch, Jonathan. So we'll talk with everybody, and only after that we'll proceed with the archival. So what is archival? We have a store ops database at the store, and we are going to create a tiny database called Store Archive, and on a periodic basis we will move the data from store ops to store ops archive. So that's basically the top 50,000 feet view. So very closely related terminologies, but I want to define them. So backup, archive, and purge. So backup is where you take a copy of the data and keep it on the same database or on a different database. Like your stakeholders will tell you that they might say, I need the data. I can afford to lose data like one day. So at that time, what you would do is you would take a backup once every day, kind of 24-hour period. Archive is where your stakeholders saying to you that, hey, for my day-to-day operations, I need only 6 months worth of data, but anything older than 6 months I don't need for my day-to-day things, but keep them in a separate database, right? I might need it. And purge is where you don't, like, where your stakeholders saying that this is this log information, or this is the quote information, I don't really need it after 6 months, so just go ahead and purge this information. So that's the difference between these three definitely like keywords. So I gave the same presentation yesterday to my team. So when I told them the same thing, they all got confused after these definitions. Like they knew what exactly that meant, but once I started explaining to them, they kind of got confused, and they were asking me all weird questions like, can you back up a archive database, or how can you archive a database already purged and all that. So then Jim Stan kind of gave me a good analogy, and he said, when you present this thing, you also have to talk about this analogy, and they will right away get it like this. And I got it actually. All my definitions are clear now. So what is this is like, if you have a shirt, and if you want to like keep it safe, and if you want another shirt, if it's your favorite shirt, what you do is you go and buy another shirt, right? That's your backup, right? And what you do is, if you have some winter clothes, you keep them in the basement when it is not winter, and that is your archive, right? You may need it later, but not now. And purge is like you are donating your stuff to Goodwill, right? So that's the difference. Like, I hope you guys got that. I got it. My fundas are clear now, right? Why archival? So there are obvious benefits: backups, restores, maintenance, troubleshoot, and all that. So I'm not going to talk about all the 101 kind of stuff, but talk about other things, some things which are not apparently visible, like replication chatter, right? Replication chatter will be very, very low when you contain the data set at the stores. There will be very less replication chatter. On the stores, we use a database, like we use SQL free version, and it can support only 10 gig, right? Some time ago, when we had SQL 2005, it used to support only 4 gig. Now we are using 2012. We recently upgraded our stores to 2012. Starting 2012, the stores support 10 gig of database. But Microsoft has not changed this upper limit. Now 2016, the next version of SQL Server, and 2017, we still have the same limit, 10 GB. So it's not going to change. What that means is, if we ever hit this limit, then we have no option. We have to either start archiving right away data, or buy license for the versions of SQL we have at the store. And the license is like $1,500 per license multiplied by 2,000 stores, right? Also, we want to keep the OLTP and OLAP, like your reporting database and your transactional database, you want to keep separate, right? That's one of the things.
Is this per database or instance?
That is per instance, per store.
Yeah.
Right.
It's per database.
The question is the 1,500 license fee, is it for an instance or is it for a per database? It is per instance, right? So other thing, the benefit of having a smaller database is that when you have a very small database, the whole like the tables can reside in the memory, and when your tables are large, they don't fit in the memory, and the data needs to be fetched from the disk. And there is a huge difference between fetching the data from the memory and fetching the data from the disk. Fetching the data from memory is like, you're here, you missed your coffee cup at your desk, so you run to your desk, get your coffee cup. That is fetching your data from the memory. And if you want the same analogy to fetch the data from the disk, so that means where is the coffee cup? Coffee cup is on the moon. So that's the difference, right? Getting the data from the memory and getting the data from the disk. So these are some of the challenges. We have 2,000 around stores. We publish 164 tables. We pull the data every 30 minutes from the store, right? It's continuous. And 15 million daily data changes, right? 2.2 terabytes of data here at home office, and 4 repositories. We have POSDB and 3 more subscriptions. It's a very complex architecture, right? two types of replication. We use merge and transactional, both type of replications. We use reverse replication. What that means is, even though home office we consider as publisher, the data is actually generated at the stores. That's why it's called reverse replication. Like the data is generated at the subscribers and it comes here and we merge it. And we have the light version which supports 10 GB max per database, and also it can handle only 1 gig of memory. And we have all these constant schema changes that goes to the stores, and the replication need to take care of all that. It's a complex architecture. So this is the data growth for one process. There's a month-end process. We pull about only 90 tables from each store, and this is for 1 year. And you can see the data growth from 530 gig in Jan to around 670 gig, right? It's like 150 gig difference. That's the growth we are talking about in 1 year for 90 tables. So quick top view of our architecture. This is we have a store like this. The data from the store comes to the staging area, the clusters we call here at home office. Data comes to clusters. Then from cluster, data goes to our POSDB or the big repository, right? This is a very top view of how the replication looks. But if you go a little deeper, not only one store, we have like 1,800 stores, right? And not only one cluster, we have like 8 clusters. Then we have 3 more subscribers, right? So you can go deeper and deeper like this, and it becomes more and more complex, right? And if you go really deep, it looks like this. And there is a story of Marconi. He's the inventor of radio, and it seems one time a lady went to him and asked him, like, you invented radio, but how does this thing work? So he, being the inventor, he realized right away that this is a lay person, and he tried to explain to her how the radio works in a lay term. And at some point she said, that's all fine, but deep inside, how does a radio really works? And Marconi said, deep inside, ma'am, even I don't know how a radio works. So that's the same thing like replication. Like, you can go to a deeper level to a certain extent. Like, I know how the metadata is captured, what kind of tables we have. We have merged tombstone, merged content, and you can go and do some tweaking. But you can only go till certain level, and after that, it gets really, really tricky. And and some of the early signs, like when we have this kind of complex systems, so things really don't crash right away, or not one fine day. Like you get early signs. So Phoenix memo is a memo created by a FBI agent. His name is Ken Williams. He was analyzing the field data, and what he noticed is there was he noticed very high number of radical fundamentalists taking aviation classes, right? And he alerted his management, right? Hey, this is something unusual. A lot of radical fundamentalists are taking aviation classes. We need to concentrate on this thing. But the management didn't listen to him, and they thought it is a false alarm. So this was reported in July 2001, and 9/11 happened in September, like just 2 months after that. So somebody really didn't pay attention to the early signs. The Challenger fiasco, this was a little more straightforward than the Phoenix memo. The people who built this shuttle, the engineers, they said the shuttle is not ready to do the launch. But the management said, no, we are doing the launch anyway. So the whole thing crashed in 72 seconds right? So Richard Feynman was involved later in this thing. He won a he had won a Nobel before, but he got involved, and he wrote a book called Surely You're Joking, Mr. Feynman, and he wrote another book afterwards called, I think, What Do You Care People Think, or something like that. And in the second book he talks about the Challenger fiasco. And what he found out is there was this O-rings. They were designed to work with extreme heat, but on the day of launch in Florida, the temperature was like 23 degrees, and they didn't really function well, and the whole thing crashed, all that. So if you want a closer to home example, so DBA team and the app support team told the management here that during the SEI transition, converting 8 stores per day is probably the ideal number, but we went ahead and did 16 conversions per day. And the first time we did that, the cluster 5 collapsed, it crashed. So, however, in our case, we had some time, so we came together right away. We had a small gathering. We had less than 5-6 hours to find out what the problem, find out the fix, deploying it to the production, and to hope that it would work the second day. And in our case, it actually worked. So we found out the fix, and we really deployed the fix, and it worked the second time. So what the fix was, we identified a couple of tables which were huge, and we decided that we will not pull data beyond certain time. Like for this item receipt log, which was taking about 4 hours to sync, so we decided that we will not pull any data older than 2015. And because of that decision, mitigation plan, we could sync the stores in time. And the second day onwards, we really did 16 to 18 conversions per day. And deep inside, what this is it is actually archiving. So we didn't pull the data beyond certain points, and that actually is archiving. POSDB recovery is like few months ago. There was some issue with the POSDB server, and we thought we'll just reboot the server, and that should fix the whole thing, we thought. And when it went down, it didn't come back for 13 hours, right? So it went down, and when it came up, it was still spinning. So we didn't know, it gave a recovery time of more than 24 hours. We had to talk to Microsoft, and they gave some solution, and we were not very comfortable with their solution. Then we ended up waiting, and it took about 13 hours to bring back POSDB. So the thing is, like, in this situation, nothing else has changed. If something like this happens in the future, it's not going to be less than 13 hours. It's going to be more than 13 hours, because the architecture is same. The only thing that is changing is the data. So we consume more and more in data. So when it happens next time, it is going to be more than 13 hours. And this is one of the stores during the SCI transition, one of the initial stores. It's taking about 9 hours to do a sync. It should not take that much time. Usually the stores sync in about 3 to 4 hours. On a day-to-day, if the store is already synced, it takes only a few minutes. But this particular time, it took about 10 hours for one store. And at the bottom, you can see here, this is the item receipt log, the same table, which has like about 700 million rows at POSDB. So same problem we are facing during the Colo migration now. So last month we were doing QA migration for Colo, and one of the servers, QA VDB 012, it has about 60 databases, and we migrated about 59 to New Jersey, and there was this one database which had one table which was like 1 terabyte of space. So it's taking 1 terabyte of space. It had about 2.8 billion rows, and we just could not migrate that kind of data to New Jersey. And we talked with the team, development team, and everybody, and we found out that only the month worth of data they were consuming. It was not required to retain the data for all the past years for their testing or development. They required data only for the last month. Time to repoll one cluster. So if a cluster goes down after 8 clusters, if one of the clusters goes down, how much time do we need to pull the data for that cluster, right? So we did this math, and each cluster talks to about 225 stores. So if a cluster goes down and if you want to pull the entire data set from all the 225 stores, so like 6 hours for one store to sync, and we have 225 stores, 2 stores at a time. We cannot do more than 2. We did 5 and the cluster crashed, right? 28 days. It's going to take 28 days if you want to pull the entire data set for 225 stores for one cluster, right? This is what is going. This is the small time. Like, you cannot squeeze this time smaller than this thing. You can say, like, I don't want these tables, a subset of tables. You can prioritize that. You can say, I want only 10 tables for the business to run. But if you want the entire thing, that's the number. Some of the options to make the things faster. You can always buy new hardware to make the things faster. You can always install the new software, like SQL 2016 is faster than 2014. So you can keep on upgrading softwares. You can tweak maintenance plans. You can tweak your code, but you can do only so much with all these options, right? Like if you notice POSDB, it's one of the beefiest servers we have. It has about 256 GB RAM. It has about 48 CPUs. Even with all this beefy architecture, it sometimes it just cries. It cannot handle the load. So the good solution would be to containing the data set at the store and at the home office, right? And this is a graph by Nassim Nicholas Taleb. He wrote a good book called Black Swan, and he says just because some systems work today is not a guarantee that it will work tomorrow as well. So this is what he calls a turkey graph. And if you see from the turkey's point of view, like it is eating and eating every day, it thinks it is healthier and healthier, and it thinks everything is going smooth. And on the D-Day, the surprise, right? So if you look at our clusters, they are working like 15 million data points changes every day. They like somebody looking from that angle, they would think it's working smoothly. But when it comes down, right, that would be the turkey day for us. So I don't like. We can still do some smaller changes. Like we have already implemented some small things. I don't feel that we are at this point at a point of no return kind of thing. We have started implementing smaller things. For example, talking about apple a day kind of thing, or 10,000 steps, or exercising. Or do this thing really work? They do. And what you do is you implement smaller changes, and over the period it adds up, right? So we started archiving 3 renewal tables, and that is a 800 million row pie, and the one in the red is 80 million, right? 60 million. So, and rest is like the one in the blue, and the one in the blue in the blue bars on the second. They are the data in the archive, right? So that's about 600 some millions. If you see the red bars, they are the transactional data for these three tables. They are like less than 100 million rows. So that is the kind of space we are going to save. And this, on these three tables, we saved about 200 gigs of space at home office, right? All right, what all things we have learned? We have learned that periodically we have to unpublish some of the tables at the stores. If you feel that some features you are not using in the app, it's better to check your apps and go back and unpublish some of the stuff. Instead of publishing the entire table, do the summary tables and keep the summary at the store and pull the summary data at the home office. That is another interesting option. And the last one is, it's not really related to the store archival, but kind of a suggestion that if you own a system, if you're an architect or an owner of a system, it's very helpful if you go back to your system every 3 or 6 months, do see what has changed, or sometimes you get a new technology, like the things you used to do in 100 lines of code, the new version of software can do it in a couple of lines, something like that. Go back and look at your systems, see what you can remove or what you can tweak, right? And these are some of the things we did in the last few years. HO replication large is a replication architecture where we used to send data from home office to the stores, and this replication used to take 40 minutes to sync one store. And I remember this thing we were discussing in one meeting in Kenasa, during Danny's time. We were talking about how to improve this replication. I remember John showed up for that meeting and he said, this is no more required because there is already a web service at the store which can get the same data, right? So we were not aware of that thing. So from 40 minutes to 0 minutes, right? So it's important that we go back to our systems and see what is required, or is there something which we are not paying attention. Like in the case of HO Bank RU, this is something Tracy Sakaloris noticed. So we are sending about 300,000 rows for each stores, and she noticed that even though we are sending this data to stores, that the stores are not consuming the entire data set. The stores are consuming only the data set for that store, and we ended up introducing a filter at the home office, and from 300,000 rows it came down to 1,000 odd rows. So from 10-minute sync time to like 1 or 2 minute sync time. So what happens is, when you have transitions like SEI buybacks, so every minute counts, and during that time this is a huge improvement. Forms data is where we used to send form related information in an XML column, and we used to replicate that to the stores, and that was a great pain for us, because this whole XML blob used to reside in a table, and sending that using replication was a big problem. And then Michael Del Fonte worked on that, and he came up with a process to push this data outside replication. And logging is the database which Peter at some point noticed that nobody is consuming that information at the home office here, and we unpublished like 80 or odd stores right away. So all that data we were pulling from the stores for this logging database, it was not required, and we stopped publishing these tables, and that was a huge performance gain too. So how does it all fit in? The store data comes to POSDB and some other subscribers. It goes from there to EDW and our enterprise data warehouse. So at this point, once the data is available in EDW, what we'll do is we'll We'll talk with all the stakeholders, like I said, Mike Moore and John and Birdwell and Mark and Jonathan. And once we confirm from all these people, we will start archiving one table at a time. The data will go to the archive database. It also goes to the bar workstation. So we take a backup every day and it goes to the bar. And there is a Afaria process which will pull the data from the store to home office. So we are not actually, there is some hesitancy that are we going to lose the data, right? So we are not going to lose the data. So data is only going to reside on a standby server. And if at any point, if we realize that we archived more than what we should have, we have the option of archiving back. We have an option of undoing it. So that is possible too. So what are we promising here? Faster customer core apps at the store. SCI transitions, right? Like next time when we do this kind of buybacks, we'll not only be doing 16, we can do more than that. We can probably do 25 or 30 in a day, right? The replication need not wait for weekends, right? Like I worked with Jonathan for about a year on adding the record modified UTC, and so we don't have to wait for weekends. Or what we can do is, like, if somebody finds out that we need to publish this thing right away, we can push a button and we can publish it during the weekdays itself. Faster recovery for store crashes, faster recovery for POSDB. So if POSDB goes down, it will come back much faster. We don't have to wait for a day. If it doesn't come back, we can spin off a server and we can initialize. We don't have to wait for 28 days to pull the data. All these things are possible. Data center migration, if we do another migration from New Jersey back to Kennesaw, so we can do it faster, right? We don't have to face all the challenges we are facing now, right? So whose baby is this anyway, right? So like, this is not my baby. I have a real baby here. Right. I'm glad that I have it. So anyway, so that's the thing. Like it is everybody's responsibility, right? It's not like, if, like, for example, if POSDB goes down today, who all are affected? It is going to be affected to every one of us. Like the finance team, they cannot run their reports. The padlock team, they cannot do the padlock payments. E-commerce team, they will be affected. Tax team, the tax database comes from the POSDB. The polling operations, they have some stored procedures in POSDB. I mean, we cannot actually operate if one of our data repositories goes down. So yeah, that's the end of my presentation. And if you have any questions, I will take at this point, or if I cannot answer, the DBA team will jump in. Yes, sir.
Is your daughter able to understand Dostoevsky?
No, she does not, but I have told her by the age of 30, this is the one book I want her to read.
Are you able to understand Cuny yet?
I'm making an effort. I like it. All right. Any more questions? Jonathan, this is your time. Yes, sir.
How aggressive do you think you can get I mean, it seems like there are a couple challenger things in front of us if we're not careful. So how quickly and aggressively can you pursue the archival?
I don't have to repeat because John already doesn't need a mic. So the plumbing is already ready. The architecture is already ready. So we have the replication, we have the database, the stored procedures that are going to archive, the jobs that are going to run. So everything is ready. If you want something to archive right now, it's possible. We can do it right now. So the plan is the two tables we identified during SCI transition, the item receipt log and the cycle count. These are the top two tables at home office. We have one is 700 million, another is like 500, 600 million, right? So if we address these two, the data will be sizably small. So what we will do is, right now we are concentrating on the colo thing. So, but next few weeks, 4 to 6 weeks, we'll be done with the colo, and right after that, we will start moving with this project. So right away, I will update the status on the store archival channel, and we will start working on these two tables, start archiving data older than 2015. So then, once these two are done, then we will talk with the business and identify the next set of tables.
What's the roughly quantify the impact of those two tables given the 2018?
Yes.
Just curious.
On the performance or the database size?
Wow, the size. What are we saying by that?
We, like for example, I have
It doesn't have to be precise. I was just curious.
I have a slide here. I guess I deleted the slide. I just don't see it.
26. Slash 26.
That's the 26? Oh yeah. Right. This is. Oh my. Okay, so this is item receipt log. 735 million rows is the current database size, and data older than that is like 519 million rows, right? It's about 60-70%. That's much data we will be archiving, keeping it at the. Yeah, the size at the data like stores doesn't really matter, because each database at the store is like 4 gig. So the space we are saving at the stores is not, like, we are not really interested in that. So what we are interested is like how much we are saving here, and more than that, not only the space, it's basically the performance and all the other benefits we will get. That is the one which we are concentrating on.
How do you arrive at, yes, this is safe we don't need this data?
Right.
And I know you vary stakeholders, and the reason I ask is, I bet there's an opportunity to probably, I wrote a bunch of stuff a long time ago that probably isn't useful, it's still probably collecting a bunch of data, so I'm curious, what's your process and methodology to really force decisions to help the problem?
Right. For these two tables, this is item receipt log, and for example, for the other table, cycle count table, and I spoke with the stakeholders, and like I spoke with Tracy Sakaloris and some other people, and many of them said we don't want this data at home office at all for cycle count log. Then I talked with the operations team, and Ray Kimbrough said he wants the data at least for a year. So earlier we were thinking of not pulling that data, then we are now ended up with at least pulling the data for 1 year. So what we have identified, or we are going to identify stakeholders, and we talk to each one of them, and whoever wants the data for the longest, we will keep that data. And we are not actually purging the data. Data is still at the store, and we are not doing in big batches. We are taking in smaller chunks, one table at a time kind of thing, and we will also not do it right away. Because even like somebody says for this table, like get rid of all the data older than 2015, we will not be able to do that. We will have to start archiving from 2011 or 2010, because that much massive replication activity is going over the network and deleting the data here. So we'll start with older than 2011, 13, and at that point somebody will start noticing, hey, you guys are really archiving older, like you should not do, and we'll have to address that at that point.
Yeah, I think it's valuable, and I bet people won't, a lot of the folks you're talking about won't fully appreciate the trade-off in a way that
Right.
everybody wants all data, right? So,
Exactly.
So
Yeah.
the root of my question is if you need any support or any tiebreaker stuff, I'm sure John will look into it.
All right.
That there is a lot out there that
Yes.
actually used, and if people think about it.
Right.
So,
Yeah, it's not only for store. We also need to go back in all our home office systems, right? One of the systems is, we were looking at one of the systems, finance systems. They have a table called HOINV as inventory information. It has like billions of rows of data, and we are not able to migrate that to Colo because it is involved in replication. It talks to a server, and another server talks back to it. It has kind of a cyclic dependency. So all these challenges we have because we have not really paid attention to archiving data.
I'm just curious. But the plans, and how you're approaching the problem, essentially the store archive channel will
Yes.
get informed there.
Yes. Yes. Yeah.
Could you possibly be archiving data per table different
Yes.
times? I'm talking about like this one is January 1st, 2015, maybe a different table will be
Yep.
January 1st, 2016.
Right. That-
They won't all be archived the same.
No, that is correct. The question is, do we have separate times for different tables we are going to archive? That is correct. We'll have a control table somewhere in our process, and we'll put the table name and the cutoff date, and it will, every time the process runs, it will talk to the control table and get the cut threshold information and archive from there. Right. Cool. I guess that's all the questions. All right. Thank you. Thank you, guys.